Right. Hi there. In today's live stream, so I've created a small plan just to make it easier for you to understand what we're going to be up to. Okay. Well, the plan for today, we are going to continue on our project, which is to train an image classification model for wildlife detection. In this case, for my garden and for my Raspberry Pi. Okay. So we've already built a data set. We have already trained the model with transfer learning using mobile set version 2. You can see the live streams as well for that. And yesterday we converted our model to Tensorflow Lite. But I kind of only managed to do that by the end of the stream, so I didn't have a chance to evaluate the TensorFlow Lite model accuracy, which is the first thing we're going to be doing today. Okay, once I've managed to do this, and for that I'm going to use first the validation dataset. In machine learning, normally you have a training dataset, validation dataset and a test dataset. The training dataset is what the model learns from. The validation dataset is what's used at the end of, normally at the end of each epoch, I think, to actually just benchmark the results of what the model has learned. So this is not, in this case we are talking about images, right? So the model itself doesn't look at the images, right? It hasn't learned from the images, so it's just using the images to do inferencing, right? We do inferencing and see how well it scores against, we compare it to the ground truth, and that's how we evaluate the accuracy of our model, the validation accuracy. And then the test data set is normally used at the very end of training, when you've already more or less confident that your model is going to be good. And the test data set is normally a smaller data set, which is independent. Yeah, that was never seen during training at all, right? And so that's the first thing the third thing we're going to do. I've already actually created a test data set. I spent some time offline, so I didn't want to bore you too much, right? So I gathered more images, right? In this case, right, our model is identifying three things, right? Foxes, cats, and birds. Yeah, nothing special. Okay. So I've created a test data set for that. And at the end, right, because we're almost at the end of the process of actually training a model. And once I've converted this to TensorFlow Lite, actually I could already deploy these in a Raspberry Pi. But it's not as simple as that. I actually want to discuss with you the next steps, if I have time. And the next steps will involve, maybe I'll try and explain to you the architecture of it's not the model itself, it's the architecture of how I'm going to do the initial motion detection with the Raspberry Pi camera using OpenCV, how I'm going to pass into a model, which is going to detect if there's people there or not. And then I'm going to pass it on to an image classification model, which is the one we've built. Okay, so I hope I have time for that. If not, then we can do it always in the next live stream. Okay, so if you have no questions, I'll be starting now. Yeah. Okay. So I'm on Kaggle. I've already run this notebook here, mainly because it normally takes a bit of time to run. If you want a detailed explanation of this notebook, you need to go to the past live streams. I'm not going to display it here. But, I've talked about this many times. Oh, it seems like it failed while running something. Why it failed here? So it ran all the way up to here. It's not clear. Labels out of bound. So it seems like this is not the same size as this. It's a bit unexpected. I wasn't expecting to get an error, but it seems like something went wrong because the training. Oh, let me see what happened there. Oh, I know what happened. No, I don't know actually. So something went wrong running this notebook again for some reason. I have to check what happened. Okay, so this looks normal. 4 classes. It picked up something new. And this is probably because it picked up the new version of the dataset, which I wasn't intending to demonstrate now. So let's see what. Okay, let's go back. So before we can start, right, with Tensorflow, I just need to fix this error. So bear with me. Because I added a new class, right, called empty, but I don't really want to use that just yet. So what I'm going to do, I'm going to delete it for now. But how do I do that? I'm going to, this is a temporary measure because until I'm ready to take this new class on board, I don't want it to interfere. Okay, so here, so I'm just going to check where it is. This should be an easy fix, actually. Okay. So I created an extra class, you know, to detect a situation where in my garden there's nothing there. But I'm not sure if I'm actually going to use it because I have other ways to determine that even before I call the model. So I wonder whether it's worth it. Okay. I hope you can see this properly, you know. Maybe I should try and increase the image size. No, just make it bigger so you don't have to strain your eyes. Can you see better? Yeah, I can see better as well. I think I'm benefiting from this. Stretch it a bit more. Okay, so this is in my garden data set. So I need to delete this directory here, empty. So I'm going to do rm-rf or fr. And it will be gone, okay, before I run anything else. So I can now, I probably should just run this again. I don't want to run everything from the beginning. Just run after, okay, so I can do this, run after. So it will not repeat what they ran before. And you try to run everything again. And we have our birds here, our cats, the pre-processing done. At some point I'm going to be adding a lot more detail into this notebook so I can explain every step. And I'll do another video, right? One of the things I'm doing here with this live stream is actually trying to prepare a video about my next video on Raspberry Pi camera with wildlife detection, right? And I just thought, okay, rather than spending a lot of time by myself doing this, why don't I just do a live stream and show you how it's actually done behind the scenes, right? This is not, you know, things will go wrong, code will fail, you get to see all of that. It's never going to, I don't think it's going to go according to the script, like if it... Anyway, this helps me prepare that video, and then hopefully you'll benefit from this. Already running anyway. Taking something is blocking it right now. Don't know what's actually running. Okay. So I have this annoying bug. I've talked about this bug many times, but right now I start on Kaggle. I want to finish on Kaggle. And at some point I will be running this notebook on my own PC or Google Colab. But the effort of trying to switch at this stage is not worth it. Always consider whether it's worth it or not. You can't upgrade TensorFlow because in Kaggle I already tried that, and what you get is like a mismatch between the TensorFlow library and the QDNN library and the CUDA library. So the CUDA is out of sync with QDNN. So it's not very helpful. So I can't do anything about it. I tried to downgrade it, but then you lose functionality that you will need. So we're stuck with this for the time being. It doesn't really help because it's hard to see the progress of the training. Can't even get to the bottom of the page. Right, but I can do this. I can just... Don't even know which one is running. Okay, we just have to wait. In the meantime, I can just go through some of the things that the TensorFlow Lite conversion, right? So why we need to convert this to TensorFlow Lite? So the TensorFlow model on its own is actually, it's basically normally too big for the Raspberry Pi. Not only like the file size is quite large, it takes a lot of space in memory. And from my own experience, because I've run like TensorFlow on the actual full model on a Raspberry Pi, it takes like minutes to load normally, because it needs to load the whole of the graph. You know, the neural network is a graph basically, with connections in between neurons. You need to load that into memory, and then it takes a long time. So that's why you normally convert the TensorFlow model to TensorFlow Lite, so you can run it in lighter devices. And there's another reason as well. One of the things that TensorFlow Lite conversion does is convert all the floating point numbers, which are used for the weights and activations in the neural network. It converts them to integers, right? So the floating point is like normally 32 bits, and we're converting that to 16-bit integers for the activations, I think, and then 8 bits for the weights. Okay, and because actually dealing with integers is a lot easier than dealing with floats, right? Many edge devices, IoT devices, they will only like be able to deal with numbers. So by actually making this conversion from TensorFlow to TensorFlow Lite, we allow the TensorFlow model to be run in very light devices as well. What else? Yeah, I think that's the main. There's also other things that the TensorFlow Lite conversion does, which is basically eliminate some connections, drops some connections between neurons. They deems that there is an algorithm and it's quite complex. And I mean, if I was able, I didn't write the code myself, so I don't necessarily know it in detail, but that's what I gather. They prune the tree, the graph in certain connections, but at the same time trying to minimize the loss in accuracy. There will always be a loss in accuracy, and that's what we're going to be checking today. You know, how much have we lost? Gosh, this is not running very fast, is it? So it's still running this section here. So this is the last experiment. And this is the actual best result. So I did a few experiments in the previous live streams. I tried to, I started with a data set I gathered of photos from the internet. I trained on that. And then I also used basically, I trained on that, right? So the training and validation data set were from the internet. It was a great accuracy. It was brilliant. Yeah, I thought it was really good. But then when I tested the model against my own images from my Raspberry Pi camera, it did really badly. And that's why I had to do some. That's why I gathered a new data set, and you'll see that I have a data set from the internet here and a garden data set. So this my garden data set is basically just photos from my own garden with the animals I get there. I didn't want to throw away the internet data set because it helped me as well to make sure that my model is not too overfitted into my own data set. And it worked quite well. So I basically concatenated both data sets. And you can do that in TensorFlow, which is quite nice. You have a concatenate function. It can't even search, but there is a method there to concatenate. And that method concatenates two data sets together. So it was very easy to do it. My kaggle is dying at the moment. I hope I don't have to restart it because okay. I think I better not do anything here. Just let it run. Okay, so I think I finished the training. Okay, that's good. So we have now, we can see the training and validation accuracy. It's actually almost like a perfect curve in my opinion, right? So the training goes up and the validation accuracy also goes up. And the loss, normally you want it to go down. So the training is more or less following, the training loss is following the validation loss, which is good. Okay. And yeah, and we have, okay, so the model, the notebook is now completed, I think. So we can already see that these are the TensorFlow Lite models, okay? And now we can do some evaluation on them. And I'm going to go into our documentation because, yeah, I was following another notebook. I need to find it again. I was doing post-training quantization. And quantization, so the TensorFlow Lite conversion model can be done either during training. I mean, you start the process during training, which means it's called quantization aware training. And the idea is you basically, you go through the whole model, you collect all the weights and all the activations, you check what's the highest and the lowest numbers. battery is going out. Hello? Seems like I'm running out of battery on this microphone. Damn it. When did it stop working? All right, I'll be away for a second. I need to see if I can get another battery for the microphone before it runs out again. All right, so Can you hear me now? I'm using my web camera microphone. I don't think that's going to be a very good sound. Yeah, but that's the only thing I have. I can't figure out this camera now. So this microphone ran out of battery and I can't switch it on yet. I'll check it later. Okay, so anyway, I was trying to run the Tensorflow Lite model before I ran out of battery. I don't know how long I was talking for without the voice, but never mind. Right, so let's see what's next. If you can't hear me, let me know. Yeah, I will fix it. Okay, so float equal to... So there's something wrong in my method. What did I do wrong? So I'm passing in positional R. Oh, I see what's wrong. Okay, so I need to make sure this comes before this one. But actually this is a bit confusing because what? So okay, so this doesn't look like yeah, it needs some work. Let's see what's wrong in this code, because it shouldn't show a white image. Oh, this debug is so annoying. So see what went wrong. We have some code here to show the image. That's the image index. And it's 1. So let's try 2 and see if it makes any difference. Just curious whether it's... Oh, okay. So this is to do with some... you have to normalize this. In this code, somewhere they divide by 255. I think it's here. Okay, so they do it here. So they're actually dividing it already by 255. So it means I need to normalize my images before I use this code. So I can copy that. I can do it here, or I can do before I call the the model itself. Test images. And I can divide it here as time. If I now run this, if I run this, to get something like this. Oops. Because I haven't done divide by. Okay, so now I can see the image, right? And it's a bird, but this label is here. Okay, true is 0. Of course, we don't know what 0 is. I think 0 is, this depends on the predictor is 2. Okay, but I think there is some work we need to do on the predictions, because the way this model works, let's see what it's actually printing out. So I need to debug this. Oh, 0. It's actually random. This is a bird, but the model is actually not returning like a single integer. It's returning like a list of values, right? Like 3, 1 for each class. So we need to go into a bit more detail to find out. Maybe our conversion of the model wasn't correct. I don't even know which model we're running. I see. This is not exactly correct. or it might not be correct. So let's see what I'm going to. Okay, I'm going to print output. I need to know what's actually returning. But it should be like a list of lists with and each element in that list will have 3 elements at least, 1 for each class. So you can see that's what I was talking about. So this is what it's returning. Okay, so the highest number should be the one that it's being identified. So in this case, actually returns the correct value, right? So 0, 1, 2, I need to print the labels because otherwise it's hard to know what this is. Okay, 1 second. Okay, so the output of arguments. So I'm just going to do some debugging here. So I just want to check that there is nothing wrong. I think this argmax does what I wanted to do, actually. So it's quite lucky, in a way, that this is not. So the reason why the predictions were wrong is probably because the model is a bit, is wrong, right? That's how it is. And I need to also change something. I've noticed every time I run this, I'm going to the next, it's basically going to the next batch. And I don't want to go to every time I run this, I don't want to go to a new batch. So I'm going to put this separately for now. So this line of code will not be called every time I'm testing the model. Okay, so if I run this again, it should always be the same image. Okay, and now I can see this looks to me like a cat. Okay, right now it's still not great. True 1, predicted 2, what is that? So the best way to fix that is by having the class labels. So I've got the name of the class labels. Classes. I think I had the variable somewhere with the classes I needed. class names, yeah, that's the one. I need to have something to change that code. Yeah, so this is interesting that it's trying to. Why does it always use 0? I'll fix that later. For now, I'm going to assume this is correct. Yeah. Seems like I've got some extra brackets for whatever reason. And let's see if this works. Predict. The str needs to be here. Yeah, predict. Maybe I need to also add str here. I think that trying to put everything in the same line is costing me already. So now I don't know what's going on. Okay, what I'm going to do, I need to undo this. I'm just going to try and do it properly. So through. We call it ground truth equal to this predicted test image label, test labels, image index. Then we have prediction, predictor, we want to call that, let's put it there. So predicted equal to class names predictions. For now I'm going to put 0 as it was before. sits there. Remove the extra square brackets. Print ground proof. Print predicted. And if I just want to see what the data type is and how it shows up to see if it's correct or not first. Okay, I can see cat, fox. Okay, that's correct. So I can put true equal to true, predicted equal to predicted. And now I should have done that. So we have, okay, in this case, true is fox and predicted is fox. This is correct. So I think the method is working. And now I need to just go to the next block and see what else they do to evaluate the model, and I'll just copy and paste that, right? So I can, oh, we can even specify the model type, yeah. Not using float. Not type. Open there. Oh, it also works. Fantastic. And I can also have this multiple times. I don't know, 3, and then image 5. It's only showed once. Why? It's before. Because I was expecting Matplotlib to print 2 images, but for whatever reason it didn't print 2 images, so I'm going to do 1 in each block. Yeah. So we have here, this is what a fox, and it's predicted fox. Here it's actually a bird. It's a bit tiny to see, but it's the wrong prediction, right? You predicted a fox, but it's not. Okay, so from like just a very rough evaluation, right, by just like doing examples, it looks like the quantized model is way less accurate than our TensorFlow model, but we will only know for sure once we actually do more evaluations, like a proper evaluation. Okay, so there's a method here that does the evaluation of the accuracy. I'm going to copy that, and I'll see if this works. I see. So what they are doing, they have the global test images and test labels, and then they are running the TensorFlow model against that. Thing is, how many samples do we need? Let's do first with a batch of 32. There was actually a method I used before, which is evaluate, right? That wouldn't work for Tensorflow, right? Let's do this. Then I'll figure out how to do for the whole data set. Oh. This is argument, of course. The images and test labels. Then run. And then model type, it will default. Let's just make sure that we have quantized. Not sure what happened there. You didn't do anything. Oh yeah, because this is just a method, and now we need to call this. I think I understand why. It seems like I'm passing the wrong number of arguments. So let's figure out where it went from. This is the method, right? So one is a run TF Lite model. It's missing. Lost it. Run TF Lite model. Yes, here. Oh, it doesn't have a model type. No, it doesn't. I'll take it away for now. I don't know why this argument is here anyway. So takes 3, but I'm giving it 4. Maybe a bit late now. 1, 2, 3, 4. Yes, I'm giving it 4. Why? Yeah. It's the labels, huh? Okay, maybe it doesn't need it. I'll find out where it's being used. Because those were the brand proof. Maybe it doesn't need it. Oh, I see. The test labels being used here. Let's see. Final model accuracy is 56%. So the fault model accuracy is 56%, which is not very good. And then, but then I've only used one batch. If I use the model type, let's see. Yeah. There is no such argument. I see. Okay, so what I need to do is so this is the actual file. I can just pass this as an argument. Okay. That's actually useless. Okay, so this is the full quantized model. That you can see the accuracy is less, even worse. But then this might be because we are not really using the full data set, right? We're only testing against subset one batch of 32 images, right? Which is it's not exactly enough. So let's see how to fix that. So this is an iterator. So I'm going to do how to actually go into up to the end without fail. So put here. So I'm just going through the whole of the data set and see if I think it should throw an exception once it gets to the end. I wanted to see also the documentation for this. As NumPy iterator, let's see, it's Tensorflow. There's a method. See some code sample. Maybe I should just, instead of trying to go through the whole data set, I could just take n elements, because I think it's a lot actually. So let me just go back to the top and see how many actually we have. So in the file, we have to be fair, we are so we have about just for training, for validation. This for internet data set. What I'm trying to understand is why it takes forever just to iterate through all the images. Shouldn't take that long. Still running. If I'm just trying to do some debugging, it's very inefficient. I don't know why it's taking so long just to go through what I thought was a small batch of images. Feed the sequence of images. If it's a NumPy array, it's going to throw an error. So there's 32, as I expected. I'm just going to also print the type of this, so I know where exactly in the documentation to go. Print type. So it's a batch dataset class. So I can just copy and paste this and get the right documentation. Need to make sure I go a little bit. This is a very recent version of Tensorflow. I'm on 2.6. No. What is that? 0.6. Let's do that. So dataset ops. Oh. It's different. do a Google for Google. Wonder if bit strange. Just going to yes. It's not very healthy, is it? A tensor of type variant. And now I have take one. Okay, so I think I found another solution. Let's see. No while true. Want to print what this returns. Instead of getting things in bytes, I'm just going to get the things I need. Make with the set. Can I do as numpy iterate? Oh, I see. instead of just getting a batch, I can just get as many as I want. Okay. Okay. Stop. Okay, so it's returning something else, which I don't know. Something. I have to figure out the types. It's a bit. So it's a NumPy iterator, but I thought, oh yeah, of course. You should have 100, I hope. No, still is going to get everything in batches. Nice. If you batch it to say after. Shuffle. Going through the docs here. This is the best way to complete it, it seems. So this is the method I used. Oh, I see. Well, I can also increase the batch size. So these are the labels, and these are the images. There's a lot of zeros. Find out what. With this error message, it's really hard to work here on Kaggle. Printing each element, and I think it's a pair. So for image label, we just try to print the label over. So this is like 32 labels at once. Okay. It seems like it works better now, because I can see just pass in test images. Maybe I just add this code inside. So I pass in the data set. Yeah. To work out this method. Right, so I get this is like batch images, yeah, labels, yeah. So I could put everything into one big list to simplify for now, but like what I would do actually, I would call to do this properly, I would actually call the runtf Lite model for each batch of images. Then I would take all the predictions and all the ground truths, and I'll put them into one big, two big lists, and then I would do the average like it's doing here. but because I'm trying to save time, so I could just do something like this is probably going to run out of memory, so let me just do this probably. Next, I had to do it here. Okay. Predictions and the labels, yeah. Images. If this is going to work. Before I start writing all this code, I'm just going to run this. Okay, next is this is where is this coming from? It's coming from here. Okay, it's calling everything. Now I'm even going to add yeah, like a string just saying what's going on. Now it's doing one batch here. And I will see. Okay, so it's doing all the batches. It's a bit slow, but yeah, it's doing something at least. So I know it's working. And what I can do, I can just start collecting all these predictions. Oh, I'm just going to need to go back to my NumPy basics. NumPy concat append to array. It's append, it's easy. Okay, np.append. Oh. Okay. So elements, predictions all, people. Then so np.append predictions all. does. Okay. So it should put all the predictions here, and then I can put labels as well. P.array, yeah, and P.end labels all with labels. Okay, so we have predictions and labels. Then the accuracy is basically checking at the end if I can just comment this in again. So I'll replace test labels with labels all, and then predictions all with predictions. And then, oh, I need to know how many images. So we're talking about, I'm just going to use one of the lists. Yeah, it should be the same. So this should give me an accuracy, and I can print this. I should have a method. I need to make sure the intent is correct. And I think with this, if I'm lucky, I'm going to be able to get basically an evaluation for the whole of the dataset, and I'm going to finish at that. Seems like it's always going to the kit here. So we know that our models is probably not as good as the full TensorFlow model, so I need to understand why that is next live stream. I'm just hoping this method works, and then I'll finish off here. Any questions? And before, I hope my microphone is working well, because I had another microphone, it ran out of battery, and I think I've been talking for a while and nobody complained about the fact they couldn't hear me, so maybe I wasn't saying anything important. Okay, this is very slow, this. Okay, seems like something went wrong. Thank you for letting me know. Alright, so number of test samples equal to 0. Obviously we had more than that. Did I just read the documentation properly? Oh, I see, I made a mistake. What's this? Should be a better way, right? Just going to flow with it for now. Not questioning too much. Predictions all. Work now. this looks so bad that I'm wondering if when I converted the TensorFlow Lite model, I used the wrong model, because I have a few experiments. I'm really hoping I didn't. I used the wrong model. Let me check. Oh, yeah. I see. I'm so glad. I used the worst model I had, and this is good because it's going to give me already a benchmark. I was wondering why it's so bad, because the TensorFlow Lite conversion shouldn't make the model so much worse. Okay, you can see this one is 41% accuracy, which is it's kind of horrible, to be honest. But there is light at the end of the day, or the night. I'm going to rerun this section where I'm converting the model, and I'm going to use the right model, which is from experiment 4. Yeah, so this is the one I'm supposed to be using. But I don't know where. No, I'm actually using it. Convert. Where did I go wrong? This is normal. No, if I used the wrong model. Just changed it, right? Okay, so I was using the wrong model for sure. So I'm just going to run this again. And I definitely will get bad results, right? And this is going to be a good way to end the night. I should get 95% accuracy, but probably will be lower because I'm simplifying the model, but you know, it shouldn't be much lower than that. Yeah. It's taking so long just for this. You can find the link for this notebook somewhere in the description if you are interested later on to check it out. So this conversion, right, it's using this method. It's a representative. This method called representative dataset is basically going. In this case, we are just going through a single batch, right? It's going through some of the images and basically it's trying to force the model to do it's doing the inferencing with the model, and the idea is to get the maximum numbers and the minimum numbers, so that when we do the TensorFlow, the conversion to TensorFlow Lite, because we're going from a bigger data type to a much smaller data type, the algorithm is actually checking the max and the mean, and it's trying to fit it into the small data type. Yeah, anyway, it's a bit complex. But that's why we need that method, just to force it to go through some of do the inferencing. Okay, see, this is accurate. It's the same, right? Okay, this one is predicting a cat. It's a cat, but then it predicted a fox. Okay, let's see if the evaluation. It was 95%, right? 95% it's not perfect. No, this is not yet running. Take a bit of time. Let's try another one. This might be. Okay, so we have these results. They're not great. I don't know what went wrong there. It might be something that's missing, like normalization of some kind. I don't even know if I did that. Maybe I'm not doing that properly, the normalization. So evaluate model. The normalization is basically making sure that instead of having each channel normally goes from 0 to 255, right? My light is gone off. Some automation at home that switches off the lights at midnight. I don't really have time now to go through this. I need to debug this for the next session, right? So we've done an evaluation of the model. The results are not really what I was hoping for, but anyway, I'm sure we can improve on that. There must be some error I've made trying to convert. Yeah, I must be missing something simple, and I'll figure out in the next live stream. I hope you enjoyed the live stream, and if you did, yeah, don't forget to click the like button, and I'll see you again soon. Happy coding!